Hello everyone, so welcome to our deep dive into the OSI model, the backbone of networking. So whether you are a beginner or looking to brush up on your knowledge, understanding the OSI model is crucial for anyone in the tech field. And in this course, we'll be covering the different topics listed as the first is OSI model introduction, the top-down flow in OSI model, the bottom-up approach in the OSI model, the functionality of each layer, and the protocols on different layers. Let us understand with the introduction of OSI model. Do you really know what OSI model is? OSI stands for Open Systems Interconnection. If we go back to the history, it was established in 1927 and was introduced in 1970s by ISO. Before this reference model, Internet world had no reference model available to understand the communication between the systems. ISO brought this reference model to make us understand the communication between the two heterogeneous hardware systems under a different set of protocols. If we take an example here, we can see we have two hardware systems here, and with the OSI model, we could easily understand the communication between the two systems. And on top of that, OSI model also gives us a clear picture about the traffic flow through a particular machine. So basically, this OSI model came with two benefits. One, it made us understood the communication between two heterogeneous systems, and it also gave us clear picture about the traffic flow through a machine. OSI model, just being a reference model, has no existence in a machine. We know it has 7 abstraction layers which help us to understand the traffic flow through a machine with different set of protocols working on each layer. We can use two approaches to understand the traffic flow through the OSI model. Either we can use top-down approach or we can use bottom-up approach. We have top-down approach starting from application layer and which ends at physical layer. And this top-down approach is usually for the machines which are generating the traffic or the machines which act as senders. We have another approach which is bottom-up approach, which starts from physical layer and ends at application layer. And this approach is usually understandable from the receiver point of end. So the major significance of the OSI model till now has been found in the area of troubleshooting. We know whenever we are stuck in any problem in the network or in a machine, we need the help of OSI model to understand the area of the problem. Or in clear terms, we need to understand where the problem lies. So these 7 layers in the OSI model helps us to check where the problem is. Also, we can easily narrow down the problem on which layer the problem lies. Once we clarify the problem layer or the layer on which the problem lies, we can easily troubleshoot the problem and fix the actual network. So this is the major significance of the OSI model, wherein it helps a lot in the field of troubleshooting. Now let us go deep into the functionalities of each layer. Since we are coming from the top, our first layer will be application layer. Its major functionalities are that it is used as a user interface, it is used as network virtual terminal, it can help in email services, it is also used as file transfer access management control. Now we will be going a bit deeper into every major functionality of the application layer. So let us start with the first functionality of application layer, which is user interface. User interface enables a user, whether a human or a software, to access the network. So it is a possible medium between your applications and your hardwares. Now taking an example of the application layer stuff on your machines. So since your machine contains 7 layers of your OSI model, now the application layer working is done all on the browsers, applications, or on the software. Let us suppose I will open one browser here, which is my Google Chrome, and all the work which I will do on the Google Chrome is done on the application layer. Suppose I am opening one new tab here and I am hitting a website called as crickbuzz.com. So you can see here crickbuzz.com gets processed and you get a response from the ClickBuzz server. So all this work which you can do by yourself as a user is done on the application layer. This is one of the prime examples. Now if we move to the next example, suppose I open any application like Paint here, and whatever work you will do on the Paint, whether you draw anything, whether you paint anything, you will do that on the application layer of this machine. So let us start with the next functionality, which is Network Virtual Terminal. If we want to go back to the Network Virtual Terminal, let us first understand what is a physical terminal. So physical terminal is any terminal, any interface through which you access any machine. And now your software terminal is actually an interface or a software interface through which you are accessing any remote host which is not available to you for the access. Now, if you want to understand this, let us take an example here. So in this diagram, you can see we have three components available. First one is physical terminal, software terminal, and the remote host. So our purpose here is to access our remote host from the physical terminal through the software terminal. So you can see here, whenever I want to access remote host from the physical terminal, I can access it only through the software terminal. So this software terminal actually works on the application layer. Now, suppose you are sitting in India and your physical terminal machine is in India and your remote host is in USA. Now, what you can do is you can actually install your software terminal on your physical terminal sitting in India, and you can access the machine in USA through this software terminal. This all work which you do through the software terminal is actually done through the application layer. Let us discuss about the third functionality of application layer, which is file transfer access and management control. This functionality of application layer allows users to access the files on the remote host, to retrieve the files from the remote host, and to modify the data in those files on the remote host. Now let us understand this with an example. We have one local machine, we have one remote machine, and if you are going to transfer files in between them, we can use file transfer protocol, which helps us to transfer files in between the machines. Now, all this work that we are going to do with the help of file transfer protocol, we can do that on the application layer. Now let us discuss about the last functionality of the application layer, which is email services. This functionality of application layer provides the base for the email services. So that means it can help us in forwarding the emails and it can help us in storing the emails. Let us understand this with an example. So we have one email client and we have one email server. If you want to transfer emails between an email client and email server or between the two servers, you will be using the SMTP protocol. And if you want to retrieve the emails from email server, then you will be using the protocol POP3. So all this work related to the email services is done on the application layer. So now let us discuss the functionalities of the presentation layer. Presentation layer actually is responsible for syntax, semantics, and formatting of the information or the data which is being transferred between the systems. The main functionalities of the presentation layer are encryption, decryption, translation, and compression. Now let us go deep into the functionalities of the presentation layer one by one. Here we are starting the functionalities of the presentation layer one by one. So our first functionality is encryption. Encryption is the process of protecting the sensitive data or the information by converting the clear text or plain text into the ciphertext. This process of encryption can be achieved by using different types of algorithms for different situations. The common algorithms used are AES, triple DES, RSA, blowfish or twofish. So the encryption used can be of two types. The first type of encryption is symmetric encryption. The second one is asymmetric encryption. Symmetric encryption is the process of encryption wherein a single common key is used for encrypting the data as well as decrypting the data. Whereas the asymmetric encryption is the process of encryption wherein two different keys are used for the encryption and decryption respectively. Now let us understand the process of encryption with the example here. We have a sender here who wants to send the message, any sensitive message to the receiver with the help of encryption. So you can see clearly here, sender is generating a sensitive message which is termed as plain text here. So this plain text is clearly readable and we can clearly see what is written in the message. Now this clear text message is taken through the encryption method, whatever method, either a symmetric encryption method or asymmetric encryption method. Let us suppose we will use symmetric encryption here. Now once this plain text is taken through the encryption method, we will use a key which is called as encryption key for encrypting this plain text data. Now, after the encryption process, this plain text gets converted into this ciphertext. See clearly, this ciphertext is not readable at all. The string looks completely out of mind. Now, once this ciphertext reaches the receiver also cannot read this data. So basically, your receiver receives the ciphertext which is encrypted. Now, this process of encryption is done on the presentation layer. We will see the decryption process on the other end. Now, let us dive deep into the second functionality of the presentation layer, which is decryption. Decryption is the process by which we decipher the encrypted text back to the plain text. Or in simple terminology, we convert the ciphertext back to the clear text. Now let us understand this with an example here. You can see our sender already generated the plain text, already encrypted that with the encryption key and converted that to the ciphertext. So receiver receives the ciphertext from the sender. Now what receiver does, it converts back the ciphertext to the plain text with the help of decryption key. Since we are using the symmetric key encryption, the same key will be used for the decryption. So this process of decryption is also done on the presentation layer to decipher the ciphertext back to the plain text. Now let us dive deep into the third functionality of the presentation layer, which is translation. Translation is the process by which we change one encoded data to the common format and then we change the common format data to the other encoded format. We use different types of encoding systems or encoding processes in this translation process. Some of the common examples are given here, like base 64 encoding or the ASCII encoding system. As we always do understand our concepts through examples, we will understand the translation process with example again. Now, here let us suppose we have one PC which has its own machine-dependent encoding format, and we have other machine which has its own machine-dependent format too. Now, let us suppose machine with format 1 is our sending machine and machine with format 2 is our receiver machine. Now, whenever the data gets generated from the machine 1, it will generate the data in the form of ABCDs. Now, this ABCD format will be converted into the binary format, which is called as common format, so that it is understood between all the intermediate devices. Now, once this binary data reaches to the receiver machine, On the presentation layer, this binary data will be again converted into the machine-dependent code of the second machine or the receiver machine. So this is what translation process is, wherein the data is translated from the first machine-dependent code to the common code. Then, after reaching the receiver station, it is again translated from common code to the machine-dependent code too. This all the process of translation happens on the presentation layer of OSI model. Now let us dive deep into the last functionality of the presentation layer, which is compression. Compression is the process of reduction of bit size in the data information, either by using the redundancy reduction process or by using the irrelevancy reduction process. This compression process is mostly useful in the transmission of multimedia or in the streaming of multimedia, which is audio or video data. Now, let us go a bit deeper into the redundancy reduction and the irrelevancy reduction. Let us discuss about the redundancy reduction now. In this technique of compression, we reduce the data by removing the redundant data or by removing the duplicate data. Now, since we remove the redundant data, this compression technique allows us to restore the data whenever we want from our compressed data. In simple terminology, we can say the data compressed can easily be restored in its original size. Now, this redundancy reduction is achieved by different types of methods. Its common method is lossless compression. And in this lossless compression technique, there are major 4 algorithms or major 4 methods which are used. The common are run length encoding, the LZW method, the Huffman coding, and the arithmetic coding. Moving to the other compression technique, which is irrelevancy reduction, we know in this compression technique, irrelevant data is removed. Whatever data is not relevant to the actual information, we try to remove that data so that we can reduce the size of actual data. Since we remove the irrelevant data, this data compression technique does not allow us to restore the original data size. And in this type of reduction, the compression method we use is lossy compression. In lossy compression, we use mainly 3 methods. The first one is discrete cosine transform, the transform encoding, and the discrete wavelength transform. So this process of compression by using the different techniques is done on the presentation layer. And to continue the functionalities of other remaining layers in the OSI model, we will be coming up with the next set of videos.